they expect about 8% of all of the world's energy to be geothermal. And remember, that's coming up from 0.0 something, right? It's just a hole in the ground, you know? We pour some water down, it boils, steam comes up, and we have either heat or power. Most of the big oil and gas companies actually have investments in geothermal already, but there is still some level of skepticism of whether it's going to be economical enough. For us at Underground Ventures is very much a goal. Can we make this field sufficiently economically attractive to those people so that they say, you know what, we could drill for oil and natural gas here, but we'd actually rather take those same rigs and those same people and drill for heat and produce heat or power because it's a better business. I think at that point, we have really done something impactful in this field.
Before we start, I want to say a quick thank you to Morning for hosting us. If you're in Paris and need space for your team, from 2 to 30 people, Morning has over 300 meeting rooms ready for your next strategic discussion. Just mention that you're coming from Hugo Roche at New Wave and you'll get 20% off. Torsten, thank you so much for coming on the show.
Thanks for having me.
Man, let's talk geothermal. I know you want to talk next-gen geothermal, but we should start with the basics. If geothermal is so good, why isn't it deployed everywhere?
That was one of the first things I asked myself when I heard about this. It seems like almost too good to be true, right? There's all this heat in the ground and it's clean and it just runs all the time. Why don't we have it everywhere? And I think the most obvious answer is that it's only really been developed where you have these existing reservoirs. So let's say you're in Iceland. There is geothermal everywhere. They use it for heating, for power, for everything, right? It's really quite amazing. Unfortunately, we're not all Iceland. And I think that is the big challenge and also the big opportunity for this field. But that is a short answer.
And so if we describe it technically, what really happens in geothermal?
Yeah, so it's important to remember there are different sort of types of geothermal. There is everything from, the most basic version is like a heat pump in your house, a ground source heat pump where you literally drill a well or you have a little web of loops under your garden and it, heats your water for your house.
How deep is that?
And that can be, the loops can be only a few meters, but a well is typically a couple 100 meters.
Okay.
So, that very shallow geothermal essentially, right? Very common in a lot of places. And not very technically complicated. All the way up to the most advanced version, where you drill really deep, multiple kilometers, you get really, really hot into the ground, and that allows you to turn water into steam, and that steam can produce power, run through a steam turbine and produce power. And so those are very different sort of levels of geothermal.
So it's the same old kind of process, which is like steam, turbine, like that hasn't changed.
Yeah, in a sense, like geothermal is really the principle of using the heat naturally occurring in the ground for purposes of power or heating or cooling. There's just a lot of ways to do it.
And okay, so when we think about where we stand today, how much of the energy that we have in the world is provided by geothermal?
Near nothing. I think 0.014% was the latest I saw. And again, huge variations here, right? If you're in Iceland, pretty much all of your heating and all of your power in residential homes in Iceland is geothermal. And if you're in many other countries, it is unheard of. So it's highly unequally distributed, if you will.
Okay, let's fast forward 10 years, 15 years. The technology is ready. How much of the world's energy could be powered by geothermal?
Well, so we don't have to speculate that much. We can ask the International Energy Agency. They have a projection. They try to look at all different types of energy and try to make their most sort of conservative or realistic projection of what's going to happen. And so they say that in about 25 years, so that's a little further ahead, they expect about 8% of all of the world's energy to be geothermal. And remember, that's coming up from 0.0 something, right? So it's an enormous increase that they expect. And that is very much because of this principle of next generation geothermal. We can get back to that, but that is their answer, not mine.
Well, I mean, let's get into it. Next gen geothermal. If I think about geothermal today, you said we are not all in Iceland. So in other words, we don't have heat that's quite close to the ground enough so that we have geothermal. What is the bottleneck? Is that we can't drill deep enough? Is that just the physics not working? Is that the economics that's not working? Like, where do we fail today?
Yeah, so I think here's probably a good time to split geothermal in a few other buckets,
Okay.
right? I talked about that very shallow, heat pump at your house, but there's also sort of a difference between whether you have a natural reservoir of water in the subsurface. So that is often called conventional geothermal or hydrothermal. So this is the idea. Now we're a little deeper than just your house. So let's say you want to do either district heating or a small power plant. So you can find this reservoir of water naturally occurring, and you drill essentially 2 wells into the ground. One that's called an injection well. You pump water through that cold water into the ground. And then you have another well sort of downstream from where that reservoir sort of naturally flows. And that is your production well. That is where you extract hot water or steam from that. So it's still a very natural process. This happens anyway through rainwater seeping through the ground, but you're just sort of making the most of it by drilling and thereby improving those channels that you have. And so that principle, conventional geothermal, you have in less than 1% of the surface of the ground, including Iceland. And so Iceland is very fortunate in the sense that it has these reservoirs, but it also has a lot of volcanic heat. So the reservoirs become really, really hot. So that is the perfect condition, right? So there are 2 things that, let's say here in the middle of Paris, actually Paris is pretty good for geothermal. Maybe let's say Copenhagen, my home city, right? That we don't have. It's both the reservoirs and the heat, the volcanic heat. So that makes geothermal possible, but more challenging.
Okay, so not only we have a problem with how deep can we go, but we also have to find a reservoir, and we also have to make sure that it's hot enough. Is that the right way to put it? Yeah,
that's right. It's really about those 2 things. And I think what is sort of a recent development in this space, and the reason why I got into the space, is a company that some people might have heard of called Fervo Energy over in the US.
IPO soon.
Yeah, exactly. It's very exciting. And so they essentially figured out one of these 2 problems. So they can't magically create heat in the ground, but they have figured out how to open a reservoir if there isn't one of these natural water layers or aquifers present in the ground. So that is sort of the invention of not of Fervo, but the people that led to that. There's a lot of government research also, but so they have fixed that problem. We still need heat in the ground.
Let's go back to this. Explain it for someone that doesn't understand anything about geothermal. How does that work?
Yes. So the idea here is that we're still drilling our 2 wells into the ground. But now imagine you're out in the desert. There's no natural rainwater. There's no water layers in the ground. So you're essentially now between those 2 wells, you're opening a reservoir between them. There are different ways to do that. The way that they do it in the West Coast is they use a variant of shale gas hydraulic fracturing, essentially a stimulation of the ground to open this reservoir. But you can also drill the reservoir or electrically stimulate it, or there are other ways that you can create a reservoir. And I think they were the first in the world to prove that not only could you open a reservoir, but you could flow water, just like in Iceland, through this sort of injection well coming out of the production well. And that was really novel to see this work in sort of an artificial geothermal system in the middle of the desert.
And that is considered next-gen geothermal then?
Correct, yeah.
Is that the only approach?
There are a lot of different designs. You could do it with multiple wells, with a single well. You can develop the reservoir in different ways, but generally next generation geothermal is really about where you're developing geothermal where there isn't such natural conditions that we have in Iceland and Northern California and other places.
And how much are we advanced on those processes? Because Fervo is going to likely IPO, but does that mean that they have the technology ready?
They were actually developed out of technology that the US government had invested into over the past 15 years or so. It's something called Forge out in Utah, where they had characterized all of the subsurface and they had done a lot of these tests. And I think what Fervo did was they said, hey, what you guys have done is a really, really useful place to start. That means that we can go and apply they came in with some oil and gas experience, and they say, we can apply that experience and those same tools to all of the work you have already done. And the combination of those 2 is what generated the Fervo that we have today, which is hopefully ready to IPO very soon.
How much of a role does oil and gas play in that industry? Because obviously oil and gas is famous for being able to drill a hole in the
That's
ground and
right.
extract something from it.
Yes.
So how does that translate to geothermal then?
Yeah, it's interesting. It's been massively useful for this field that we can rely on so much experience from that world. The oil and gas industry, I feel like in Northern Europe, we often, have this idea that we're in an energy transition and that we're all only building wind and solar, and the climate is getting a bit better. But in reality, around the world today, we're drilling about 85,000 oil and gas wells every year. So it is an enormous amount of oil and gas activity. And of course, what we're trying to do, and many people are trying to do, is to move that activity into something else.
Hmm.
But I bring that up because that is an amazing experience to have when you go into a field that needs wells, not for oil and gas, but for the extraction of heat. So having not just the experience, the people, the tools, the rigs, all of the investments into this space is enormously useful for us to roll this out fast.
So is Total Energy or some of the similar companies are going to be the next players in geothermal?
Yeah, I mean, most of the big oil and gas companies actually have investments in geothermal already through either their venture arms or strategic investments. So I think everyone is looking at it, but I think there is still some level of skepticism of whether it's going to be economical enough. Because that at the end goal, at least for me and for us at Underground Ventures, is very much a goal. Can we make this field sufficiently economically attractive to those people so that they say, you know what, we could drill for oil and natural gas here, but we'd actually rather take those same rigs and those same people and drill for heat and produce heat or power because it's a better business. I think at that point, we have really done something impactful in this field, when it's a no-brainer.
How far are we from that moment?
That's a good question because oil and gas prices vary a lot. There are times where they've been very high and very low, and these companies have to sort of project: is it going to be worth it for me in a few years to produce here? It's a complicated answer when it's worth it. I think on the other hand, you also have electricity and heating prices fluctuating. It's not all about price. If you're a data center, it's really all about reliability. So you might choose geothermal or nuclear at a higher price than you would wind and solar because you want the reliability of it running all the time. So it's at both sides are not sort of exact answers. But by and large, I think we can all agree that geothermal's capex, as in the cost to build these systems, have to come down in order for this to be attractive to oil and gas companies. That's the primary challenge.
Yeah, because one of the things we haven't mentioned so far actually is that geothermal is not only resilient, but local, abundant. It's base power, so it's running 24/7. So there is a lot within that which is attractive for the grid, basically. You were talking about the heat. Is that also one of the use cases? Can we imagine a world where rather than producing electricity, we just take the heat from the ground and use it for the industry, for example?
Absolutely. And I think that is, there's a little bit of a difference between the US and Europe here, in that Europe is generally has a premium for heat production. We're really interested in clean, reliable heat, ideally not using any natural gas from countries we don't want to work with. So here in Europe, heat is really in high demand, whereas in the US, power is in high demand, and it's driven by data center build out and hype, I think is fair to say, but it's also just a general electrification of society. The US has seen flat electricity production rates for about 20 years, and all of a sudden they're seeing a quite steep increase. So there's sort of, generally speaking, more interest in producing electricity in the US and more interested in producing heat in Europe, either for district heating or industrial heating. And geothermal can do both. So we can use the same technologies, which is nice.
You were talking about the economics of it. I want to drill a little bit, no pun intended, but drill a little bit into it. When we say it has to be competitive, what is the competition we're playing against? Because obviously, as you said, the world is electrifying. That's a trend. We know that for sure. Now, are we competing against nuclear fusion? Are we competing against fission, against solar, against wind? What's the competition really? And so at which price do we have to get?
Yeah, so let's focus on electricity for a moment, because obviously, for all the joys of wind power, it's not going to heat anyone's houses anytime soon, right? So let's talk about electricity. Um, I think electricity, when you think about back to that International Energy Agency projection, they're expecting electricity consumption to roughly double over the next 25 years from where we are today, just globally, and again, that's not all data centers. I know we talk a lot about them, but it's a general electrification of society. So most of that growth is actually going to be outside of North America and Europe, which is also really interesting from a technology deployment point of view. So just like that's the long perspective. This is the full picture, right? So how are we going to build out twice as much electricity production ability? That's not trivial at all. So I am of the opinion that we don't actually have to compete with wind and solar and nuclear and fusion and all these things, because we're going to need all of it. Everything, everywhere, all at once, essentially, is the answer here. And where we are not building out enough new types of energy, the fossil fuel world is going to fill it with natural gas plants and essentially coal plants, either new coal or not retiring old coal. So we know we will build it. What we don't know is what kind of technology we'll build. And my guess is that we are not going to see the primary problem as, are we competing against nuclear fusion or nuclear fission? Or, we are going to need to build out what's fast and cheap and, clean and reliable as soon as we can. Of course, you could have in individual places. You could have a choice. Am I going to build a nuclear, power plant or geothermal, or what am I doing? So to some extent, this is important. But for us, again, we're sort of, the overarching goal is to bring down the cost enough that we can unlock oil and gas infrastructure and equipment. And at that point, it is going to be inexpensive enough to be the sort of option of choice. That is at least the path that we are on with this technology.
One of the components that's interesting, as you said, is a geographical need for electricity. The reason why is, when I think about geothermal, I couldn't think about something that wouldn't be able to move less than a geothermal power plant, right? You can transport the electricity, but we are not good at it so far. In other words, if you produce electricity in Europe and want to move it to America, for example, that's going to be quite difficult. So how do we think about that?
Yes, you're right. And I would say especially fossil fuels are very easy to transport, right? The US is producing gas that is consumed by Europe because they're liquefying it and transporting it, right? I mean, geothermal does not have that advantage. And our sort of path to dealing with that is to get towards geothermal anywhere. Essentially, getting enough of a design and economics in this field so that we can build geothermal heating, cooling, and power plants anywhere. And that does mean slightly different strategies in different places. For instance, we might, in the western US, there's a lot of hydraulic fracturing stimulation used to create these reservoirs. But in a lot of places in Europe, we are not going to be doing that, at least not anytime soon. So we're going to need to make sure that we have other solutions like drilled reservoirs that we can build in those places where that is the right path. So I think that is the answer to it. And I think it's actually a good answer, because it's not necessarily great for either reliability or geopolitics or even the climate that we have to transport energy from one place to the other. Much better if we could just generate it locally where it's needed, right? Next to a data center, next to a city or a town. That I think either way for humanity should be the answer.
And when we think about the future, so you said, for example, next to a data center, can we imagine a world where we have small-scale, couple of megawatts geothermal plants, or are we more thinking the mega kind of 400 more kind of megawatt plants that we will need in the future? Does the economics work if we do just a small plant? And do we have an incentive to do so?
The short answer is yes. Geothermal very much is very unit-based. You do it sort of per well. You drill a well and you have a reservoir connected to that well, and that well produces X megawatts that you then either use as heat or convert into electricity. So the simple answer is yes, you can just drill more wells and get more power. I think in terms of data centers, we kind of have the opposite problem at the moment, in that data centers are now so large that they're in the hundreds of megawatts of what their demands are. So they have the opposite ask. They are like, can you build something big enough locally here next to this data center that'll actually provide us with at least power, but ideally also some cooling capabilities. That would be the ideal scenario of being able to both cool and power, right? But I think next to, let's say you have a small town of 10,000 or 50,000 people, I would love to see just a single well, a couple of wells that could go through a very small, turbine and produce enough power for that town. I think it would be such a great way to be able to power and give that town the energy independence. I think that a lot of people will feel good about. So at least that's what I see happening in the field and would like to see more of.
Yeah, energy independence is quite a hot topic, obviously. Look, let's talk about what you're doing with underground ventures, because I think, first of all, it's quite unique. I don't know that many geothermal funds. But also because from a strategy perspective, what you told me before is that you don't want to invest in the energy producer, which doesn't surprise me for a VC fund, because I think those are more kind of infra projects, but that's maybe where we start. What makes geothermal investable from a VC perspective? Because, in my mind, I have these big geothermal power plants with like deep hole, and I'm like, that's just an infrastructure. That's a big infrastructure play, and an infrastructure fund is going to be able to finance that, not a VC fund. So how do we think about that?
No, you are absolutely right, and that is why we started Underground Ventures. Essentially, that is the joy and beauty of geothermal energy. It's just a hole in the ground. We don't need to get import plutonium or invent fusion at a sufficiently efficient level, low cost level. It's just a hole in the ground, and we have naturally occurring heat in the subsurface. We pour some water down, it boils, steam comes up, and we have either heat or power, right? So that is exactly why. Why wouldn't we try to invest in the technologies that allow that to happen as cheaply, efficiently, and reliably as possible anywhere in the world? So these are things like advanced drilling. It could be how we case and complete the wells, essentially make them ready for production over 30 years. That's not the same as just drilling a hole in the ground, right? You got to make them really sturdy and reliable. Things like how the water flows in the subsurface. So this is called flow control. How do you make sure that water actually is using the reservoir that you created so it heats up enough and doesn't just take the quickest path over to the production well and then it heats up a little bit, but you didn't really get much energy out of it. So flow control is important. How about how we convert, let's say you get steam up of this well, how do we efficiently convert that into power? Well, that whole field hasn't seen any innovation for 30, 40 years. We're really just like having a few companies around the world build turbines. It takes them years to build these things. So can we modularize or containerize or, somehow make that process really efficient and fast and deployable? So there's all these different disciplines within what I would call tools and technologies that are not necessarily the same as having to go out and acquire a land lease and start drilling and take on the risk of an infrastructure project and sign PPAs with people. That's another game. That's not for us. But certainly we're investing in those technologies and tools that are being used by all of those, let's call them developers that are out there, including Fervo, for instance.
So that's a pick and shovel strategy, as we call
it. That's exactly
right. Don't you have a risk with that, which is if you invest in a technology on its own and then the rest of the supply chain is not building fast enough, then it's basically useless?
Yes, and I would say the other way around too. We can invest in amazing drilling technology, but if the field of geothermal is not actually being deployed fast enough, right, then we risk having been too early in that journey. But I think the slightly more complicated answer is that these two things depend on each other quite a lot. So we see now geothermal projects that are being proposed because of the advent of technology that we have invested into. So we are enabling already with the first couple of companies that people say we couldn't before build geothermal here, but with these things, we can now actually reliably, economically build geothermal. So we are certainly hoping that these two things go hand in hand. But you are right. It's a sort of a concentration of risk that's not very normal for a venture firm. And that is both good and bad.
And talking about concentration, because I think that's quite important to stop there. Because before coming to this episode, I was thinking, all right, those guys are doing only one theme, which is geothermal, so one field. They're going to do 10 investments, from what I know from your fund. So not only you have a concentration in terms of the industry, but also in terms of the companies. How do we think about that? Because it's super risky.
That is correct.
You might lose it all, right? Like if the field doesn't develop fast enough, then you might be just wrong completely.
Yes, that is correct. And so, first of all, we are a relatively small fund. We have a total of $40 million in total in the fund. And of course, is that a lot or not a lot? It's a lot of money, but in energy infrastructure, it's not a lot of money. A single geothermal power plant could easily cost $40 million to make. So it's a very, very specialized fund. We're going in the very early phases of these companies, typically investing between $500,000 and $2 million per sort of first investment in these companies. Very often leading these investments. That means taking a board seat and working with the founders. We are ex-founders ourselves, so we feel good about the technical challenge and sort of early founder challenge. So yes, it is a concentration of risk. I think the risk that we are very aware of and have decided to take is that of, is next-gen geothermal going to happen or not? Basically, if that is not happening, this is probably not going to be a great investment, not for financial returns and not for climate impact either. But I think for all of the other types of risks, we're actually very distributed in how we place our bets. For instance, having this sort of, some of it is drilling, some of it is power conversion, some of it is flow control. These things can also be used for other things, If we end up seeing Fervo being the one solution that wins everything here, it's possible that some of our portfolio companies might not be as relevant and others are more relevant. So within that field, we're hedging our bets. We're also, as far as we can, trying to not invest in competing technologies. So even though you're right, it's the same market, there's definitely a risk of conflicts of interest. We're trying to make sure that we have a cohort of founders in these companies that feel good about sharing insights with each other and learnings with each other, that there's trust built between these companies because they are not competing with each other. So that is you can never guarantee that, but it's the hope that we can create a very symbiotic relationship between these companies because it's the same field. So for instance, we can, next week we're gathering all of them in Germany at something called Geothermal Offenburg, which is the biggest European geothermal conference. And we can bring in advisors or experts that are relevant to pretty much the whole portfolio. And that is quite unique for a venture firm, right? That it's so specialized that we can actually add a lot of value to the companies concurrently. We have, geothermal technology expert on staff that comes out of this field. What other venture firms have that, right? It's a very, you get a lot of benefits out of being so specialized. But I agree with you. It's a concentration of risk and certainly also has its challenges.
Is this a winner-take-all market?
That is very hard to say. I think we are of the opinion that generally it is not. And the reason for that is that if you look at, let's say we compare to wind or solar. Now, these two fields have not shown to be a winner-takes-all market, but there are certainly concentrations in the market, for instance, the supply chain. 90% of all the solar cells are coming from China, for instance. And a big part of the reason why wind and solar has come down in price as much as it has is that they are mass manufactured. They are units. They look the same, every place that you put these things up, it's the same thing. So geothermal doesn't quite have that benefit because you're still dealing with the subsurface. The geology is different. You might have local regulations that are different. You might have, financial situations that means that a certain type of investment is easier in one place than the other. So they don't really have that advantage. And for that reason, I think it's more likely that we're going to see a more unified technology stack or the sort of supply chain, as you mentioned it, and that is being picked and chosen, and then there are local developers essentially saying, well, here, I am the expert in this local area, this geology or this regulatory environment, and then they will pull in from these different companies, right? It's a little bit similar to oil and gas in the sense that you have a couple of very large oil majors that are going out and taking risk at certain places and developing, but they really are pulling in the same service providers for all of these places, right? So there is a very sort of finely grained service provider network within oilfield services, but you still have each well and each geology being very different.
How do you assess companies today? Because I would assume that you basically see 100% of the companies that are building geothermal, or about 100%, I hope, at least.
It's very rare that we see a venture round in geothermal that we haven't already seen. That is true, yes.
So how do you make the comparison today? Because it's a very technical field. It is, as you said, varies a lot between different places. So the geology, for example, is a big aspect of it. The Earth is not equivalent everywhere you go. How do you decide who gets funded, basically?
Yeah, I think every VC will have their own opinions about what it takes to get funded, but mostly they are sort of general considerations. Amazing team, amazing technology, have seen an opportunity in the market. All of this also goes for geothermal, but I think because it's such a specific market, and as you said, we are seeing pretty much everything. We are, to my knowledge, the only geothermal specific venture firm on the planet. So we don't have the luxury that other top tier VC firms have of just saying, oh, I've seen 1,000 startups and we picked 10 this year, right? We do have to live with quite a lot of imperfections. I think that's fair to say. And one of those imperfections is that you have a team that might be really smart and experienced in the field that they're in, be it drilling or geology or whatever it is, but may not have much experience building a startup or taking venture funding or building out sort of, they may have more of a corporate background, more of an engineering background. So that is a type of risk that we have to take if we want to be able to do anything useful in this field. And we are taking. And I think that's where it really helps to be former founders, technical founders, first of all, and that we are able to go in early. So before they get too set up in the wrong ways, getting the wrong investors on board or the wrong advisors, we can go in and help them as peers build these companies. Mm-hmm. So it is a little more handheld, which is why I'm happy we have a maximum of 10 portfolio companies as opposed to, let's say, 40, which is quite normal in bigger VC funds, right? We can really, I feel like, spend more time with these teams than normal funds can.
If I want to invest in geothermal, what should I look for this year in 2026? What are the exciting topics, exciting companies, or difficult problems to solve?
Yeah. Well, let's start with Fervo's IPO, because Fervo Energy is sort of the poster child of the industry. It came out of Stanford's program and a bunch of people with experience in oil and gas, and is really quite an impressive execution, I would say. They have raised, well over $1 billion already, and have drilled the first 30 wells in Nevada and Utah. Have shown that they have flown water. It really on every level is a really impressive undertaking. I think there are, first of all, a number of technologies around what Fervo is doing that people are working on that can be really interesting. Last week, I was at Stanford for something called the Stanford Geothermal Workshop, which is an academic gathering of about 400 scientists in this field. I felt some of it was a little over my head, but it was a great learning experience. There are a lot of people that are working on things that could make a site or development like Fervo's more efficient, or faster to deploy, or lower cost, or better performance, or better monitoring of seismic events, and like all this stuff you have to do this properly. And so those types of companies, I think, are good bets to look at who can make Fervo even better, basically.
But you only have one customer.
Yes, but remember that this is using a lot of existing technologies. Mm-hmm. So you could absolutely, we do see, there's a term in the industry called Fervo follower. That means all of the other companies that are trying to do parts of what Fervo is doing in their own geology, in their own sites, right? So still using the same oil and gas pipeline and infrastructure and people for this. So there are already a number of other clients for this. And of course, the bet you would have to take as an investor in this field is that this is going to be way bigger than Fervo. I think that is, if you don't believe that, I agree. This is not a good investment thesis. So that's a good place to look. I think there's also, outside of what Fervo is doing, some really interesting opportunities. I think when you look at heating and cooling, if you go all the way to shallow geothermal, the main reason why we don't have this in every household, at least outside of major cities, is that it's expensive. It's just cheaper to put up a gas boiler or, if you have district heating available, to get that plugged in. So if we can bring down the cost of drilling and essentially setting up these heat pumps, you have an enormous market in front of you, because it's, very cheap to run. It's completely reliable. It's climate friendly. There's no CO2 emissions. Basically, no reason you wouldn't do this other than you have to drill in order to make it happen, which can be expensive. So that is another field. We invested in a Swiss company that's drilling fully without a rig and, fully electric, fully automated. You don't need to be on site preparing the well for production as a part of the operations. There are some people doing amazing things in shallow drilling. They're just not Fervo, so we don't hear enough about them. They didn't raise $1 billion.
Not yet.
But think about how many houses there are around the world and small commercial buildings that need heating, right? Especially out in slightly rural areas.
Mm-hmm.
So that is another area. And then I think maybe the third area I'd look at is what's often called super hot rock. So this is the field of, if we were to pick the perfect temperature for really high performance geothermal power production, what would that be? And it turns out that temperature is a bit higher than what you can easily deploy oil and gas equipment for, because oil and gas has never needed to go really deep and really hot. So most oil and gas drilling equipment and electronics essentially cap out at about 200 degrees C. So some a little bit below that, some slightly above it, but generally about 200, which is why that is where Fervo is sort of predominantly operating. Now, if you were to go up to 400 C, and hence the name super hot rock, it sounds very sexy. You are at 400 C and you get not only a lot more energy packed into your steam, just per mass volume of steam here, more energy into the steam, but you also get something else that's very important, which is the conversion of steam to electricity is much more efficient at 400 C than it is at 200 C.
Why is that?
So the idea here is that it's really following the Carnot efficiency. The idea is that if you run this through a turbine at a much higher temperature, that turbine converts the inherent energy in the steam flow into mechanical energy, which is what drives the turbine and produces power much more efficiently. And you go from about 12 to 15% efficiency at about 180, 200 C, all the way up to 40, maybe even 50% efficiency. So think about this for a moment. You have more energy per mass, you have higher efficiency. So the same well, the same diameter, the same cost essentially of that well could maybe produce 6 to 10 times as much power. So back to this original challenge of how do we make this affordable? How do we make this compete so that the oil and gas people are like putting all their equipment into this? If we run it at a higher temperature, it becomes incredibly efficient in terms of financial performance, economical performance. However, there are some engineering challenges in making that happen. You need to invest in better drilling and better insulation of your wells. You have corrosion issues. There's also some other stuff happening. But I think our view on that is that, well, that's engineering. Mm-hmm. That's not science. It's not an invention we're waiting for. It's really just engineering. And 400 C, it sounds fancy, but like it's the temperature of a pizza oven. Like it's not insane to be able to put water and steam through a pizza oven, right? So all of this is possible. It's just we have to develop that and focus on that. And that, I think, is also a massive investment opportunity. But we're a little further ahead here. Mm-hmm. This is not what's happening today. It's what hopefully is happening tomorrow.
And when I hear that story, I'm wondering, do we have a good understanding already of like what's happening under Earth? In other words, do we have like a Google map for geothermal that exists where we know exactly the type of rocks that we have, where the hot rocks sits, Where is heat coming from? Like, do we have an understanding of that today?
We have a pretty good understanding. First of all, again, from 85,000 wells drilled a year by the oil and gas industry, we know a lot about the subsurface. But also specific to geothermal, there's a nonprofit called Project Innerspace that made an open source map called GeoMap, GEO map, that you can access. And you can go and look up, the Parisian Basin and understand what is more or less what's called the thermal gradient. So when do we expect temperature to be high enough to produce at what depth, and what is the geology we're going through? If it's sort of sedimentary rock, it's a lot easier and faster to drill into. If it's basement rock, granite, you can still drill in it. It's just as more complicated and more costly and is slower. So understanding the sort of techno-economics, they have a great tool for that, on GeoMap. And there are other developments also in this space, but I might as well mention the one that's widely used and free to access. So by all means, you should go check that out.
Great. Well, look, you're, I think, 2 years into the fund.
Yes.
What did you get wrong so far?
Ooh, that's a good question. The strategy of picks and shovels, as you said, we feel really good about. But I also have to admit that about 85% of all financing of next-gen geothermal has gone into developers. Essentially Fervo, Ever, Sage, and a number of others, Quays, that are out there signing power purchase agreements and building their own sites, right? They're also more capital intensive, so it's not weird. But you have to admit that as a VC, you have to consider, if 85% of the money in my field is going elsewhere, am I really doing this right? So I'm not willing to say that we're not. I'm just saying the verdict is still out on that strategy. And I also think that there is a future where we might go in and place one or two investments into what I would call technology-enabled developer. But so far, at least, we haven't, and I feel pretty good about that. Particularly because we are, helping all of these other developers with the portfolio companies and all the great products they have. I think having a total of 40 million, it's not doing something wrong. It is a limitation. Like, to really do this well, Fervo again has raised over $1 billion. Like, you will at some point need more money in order to do this really well. If you don't want to be cut out by others later in these rounds, or as they sort of merge into other companies, or whatever happens, right? So that can also be an interesting question. Is it a right amount of money? I don't think it's interesting, actually. I would have thought by now that we would have a handful of other geothermal specific sort of specialized venture firms. It's weird that we are still the only one, and that also makes you sort of second guess a bit, right? Is this the right timing? I really feel good about it. That's the good thing. Like, I feel good about it, but I don't have the evidence yet to show you, yes, this is actually working out. So there is an element of belief, and thankfully we are a single LP firm. So my partner in the business is solely funding the fund out of his private wealth, and that means that we have the luxury of, as long as he believes in the mission as much as I do, we don't have to worry too much about it. We can stick to our guns, and we can decide to change if we want to. So that is a luxury. It's important to remember that's a privilege. It's a luxury that most VC firms of the same size do not have. And that is, in fact, why we could start this off as early as we did, as specialized as we did, because we didn't have to go out there and sell it to a bunch of maybe risk-averse LPs out there. So we did it with conviction. So far, I feel good about it. I'd honestly rather have you ask me maybe in a year or 2 years from now what went wrong. I might have a clearer picture of it. So far, I feel good about it.
Yeah, I think it takes some sort of very strong conviction to be able to say we are the only one doing that and it's going to work. What I like about it is, as you said, you founded a company before, and I think it feels like a little bit of the same story. While in reality, on the VC point of view, most people have somehow of a similar thesis. And when you're a founder, you usually have this, belief in this idea that you have that no one else has. And so I think it goes back to, I think your background is quite aligned to what you're doing today. Good. On the other side, what did you get right the last 2 years?
I think backing companies and people that have put their product and science first and are not too sort of focused on all the other stuff right away. That is also a sort of little bit of a contrarian view, that you're backing these engineering heavy teams that may have I often joke and saying, if the pitch deck is too polished, it's not for us. It kind of has to have this feeling of, this is early, these people are technical, we are here because of what they know and have done in the past. We're not here because of their abilities to pitch to investors, right? And so that, I feel very good about that choice. And I definitely see some of the other companies getting funded in this space, in my opinion, are better at fundraising than they are at building their product. And I think we will see how that turns out over the next number of years. But certainly, I think it was a good choice to be specialized and to further develop the expertise in the field to really understand what these people are doing and where these products are going to fill in. That has been really good. We'll never know if we're right, or we won't know for a while if we're right, because so many things are not about that, right? You could have the most amazing product and the field just goes elsewhere, and then no one wants to buy your product, right? This is a story of so many startups and other industries, right? So it's not all about that, but I feel good about having been very focused on that product and technical background and skill set before making investments.
All right, one last question for you today. What's missing in the geothermal stack? Kind of, if we think about policy, if we think anything that comes to mind, like if you could do a couple of wishes and say that's going to happen tomorrow, what would that be?
Yeah, I think in terms of technology, there are some gaps where I'd love to see more founders and more startups because the opportunity is really big. I think, first of all, in steam to power conversion, I'd like to see more people take on the incumbents in the industry with various designs, whether it's organic Rankine cycle or a supercritical CO2. There's a number of different cycles. I don't want to get into it here, but let's see some more pitches there. I'd also like to see more pitches in well casing and completion. So how do we get these wells ready for production? That is a very costly and complicated affair. It doesn't have to be. We just need to think of it from a material science point of view and from an engineering point of view. I think on the drilling and reservoir side, there's a lot going on. I think I'm willing to wait it out a little bit and see what happens, but I'd always like to see more people doing things better and at higher temperature especially. That would be nice. You mentioned policy regulation. Yes, it's not perfect. I was just at the IEA Innovation Forum yesterday here in Paris. And there are a lot of people from different energy and climate companies that have all sorts of policy reasons why what they're doing is not happening. And I think we can also come up with some geothermal ones, absolutely. But I don't want to fall into the trap of being a victim of policy not happening. Like, this is our problem to solve. We have to make this technology cheap and fast and reliable and safe, and the rest will come. But yes, the easiest thing to say is compare the US to Europe. The US is very concerted in getting geothermal deployed. They have funded it from the federal government side for 20 years. They are very particular about energy sovereignty and energy security, domestic energy production, powering their data centers. They just want to see it happen, and they are incredibly supportive under current administration and under past administrations, basically. Whereas in Europe, everything is sort of local up to each country, and there's lobbyists, all over the place for all sorts of things. And it is much harder for a European geothermal technology company and developer to get anywhere, unfortunately. And it should be totally the European cause of, homegrown, clean, reliable energy without importing gas from Russia or the US for that matter. Like, it is so obvious that we should do this, yet we are all stuck in discussions and EU roadmaps. And I really got a little annoyed by all the stuff I heard yesterday, all the things other people have to do to make this field happen, right? So anyway, I don't want to turn into a rant, but yeah, we could do a lot more.
Great. Well, look, it's been such a pleasure having you on the show today. I think I learned a lot, and I hope people have learned a lot as well with you. If people want to reach out to you, what's the best way?
You can find me on LinkedIn, or you can go to ugb.co, our website, or send me an email. I'm not hard to find. Geothermal investor, specialized in geothermal investor. I'm probably the only one. We are the only one out there, so I'm sure you'll find me.
Great. And then who should be next for an interview?
Ooh,
another investor in climate that you like.
I think I'd like to know what lower carbon capital is doing next. That would be nice. I also think it'd be nice to know what breakthrough energy is doing. There's been a lot of disruptions there. I would like to know what Bezos' Earth Fund is doing. So Jeff Bezos has a $10 billion philanthropic fund for climate, which also includes energy. These are enormous, players, and I'd like to hear what they're doing.
I would love as well, so I'll try to get them on the show. Well, listeners, if you like this episode and if you like the show, don't forget to like, comment, and subscribe if you're on YouTube, or to give us a follow and a 5-star review on Apple Podcasts and Spotify. Thank you so much for today, Torsten.
Thank you for having me.